All right, Workplace Apprentice 20 fans, welcome to our video here, and today's topic is simplifying fractions. All right, as you can see here with the notes, it says equivalent fractions are two or more fractions that have equal values. To find an equivalent fraction, you can multiply or divide both parts of the fraction by the same number. And as you can see here, this would be multiplied by 2, this would be multiplied by 2, this would have been multiplied by 5, and this would have been multiplied by 5. So as we take a look here and we look at the equivalent fractions here, we could do something as easy as if we multiply this by 2, we also have to multiply the bottom by 2. 2 times 2 is 4, and 3 times 2 is 6. So 4 over 6 is an equivalent fraction of 2 over 3. Give the rest of them a shot and see how you do. Alright, so let's take a look at that another part of fractions. And we usually write fractions in lowest terms. This is the simplest form to write a fraction. To reduce a fraction to the simplest form, or the lowest terms, you must simply divide both parts of the fraction by the same number, creating an equivalent fraction. There are no more common factors to divide by other than 1. So when we look here at this first one, we notice here we have an 8, and we know here that we have a 10. So to take it back a little bit, we would look at the factors of 8, which are 1 and 8, 2 and 4, and there are 8 no more. For 10, we have 1 and 10, and 2 and 5. So we see that the greatest common factor here is 2. So 2 has to go into both of those numbers. So when we go 8 and we divide that by 2, we get 4. And we go 10 and divide that by 2, and we get 5. There are no other factors of 4 and 5 that we could go in other than 1. So this would be the lowest term. All right, so that means that 8 over 10 is exactly the same fraction, well, equivalent to 4 over 5. And I'd like you to try the rest and do the simplifying fraction worksheet. Moving along, let's take a look at ratios and proportions. All of these topics here are really important to be able to do the rest of the unit. If you don't understand fractions and how to do ratios and proportions, you're going to have a difficult time. So please come and see me, or email me, or let me know somehow if you are having some problems with this so we can help you out. There's a very close relationship between fractions and ratios. A ratio is a comparison of two or more numbers. Order is very important in ratios. For example, if there are 3 red marbles and 4 green marbles, the ratio of red marbles to green marbles would look like this. Notice the 3 comes in, then the colon, and then the 4 comes in. It reads as 3 over 4. So hopefully that makes sense. The ratio of green marbles to red marbles will look like this, because green came first. That's why we have 4, and then a colon over 3. It reads as 3 to 4. So when we look at some of the examples here with our little toy friends here in a toy box, we want to figure out, for example, dogs to teddies. So we would take a look and we'd go, first of all, we would look at the dogs. There's 1, 2, 3, 4, 5 dogs. So we would start with 5 and then put the colon, and now the next thing it asks for is teddies. So teddies, we have 1, we have 2, we have 3, and we have 4. So therefore the ratio of dogs to teddies is 5 to 4. Now you can try the rest with the toy box there and see what you can do for the ratios. Let's carry on here. A little bit with ratios can be simplified to lowest terms, just like our friends the fractions. All right, divide both parts of the ratio by the same number until there are no common factors. So again, when we let's take a look at A. Sure. So with A, I'm just going to do the work over here. We have 1 and 6 being factors of 6, and 2 and 3. If we look at the 8, we have 1 and 8, and 2 and 4. Okay, and as we had before, you can see here 2 is the greatest common factor. So 2 would go both into those. So if we divide 6 by 2, we get 3, and if we divide 8 by 2, we get 4. So the lowest terms in this ratio would be 3 to 4. Try the rest and see how you make out. Alright, ratios are also often written as fractions. So you can see that there's a lot of relationship between fractions and ratios and percents and decimals, and if we can understand how to do that, we'll do really well on this. So when you want to write each ratio as a fraction in simplest form, when you take a look at this, we would say basically that we would go, well, in a fraction simplest form, we'd have 12 over 36, right, in simplest form. Just quickly here, you see that 12 is actually the greatest common factor, and we get 1 to 3, right? So also, if we wanted to show that as our fraction, our ratio, we could also go 1 to 3 in that format as well. Okay, try the rest and see what you can do with those. The last part that we want to take a look at here is proportions. It's simply two fractions that are equivalent, equal to each other. All right. Proportions are used to find missing pieces of information. To solve a proportion, simply cross, multiply, and divide. That's a huge skill that you're going to need in order to isolate the unknown variable. And there goes math, always looking for their x, hey? Hey, math, just let your x go. It's all good. Just a joke. All right, to isolate a variable simply means to get it by itself. So we want to find out what x is. And if you looked at before, we figured out how to do equivalent fractions. So there's a couple of ways to do this. Now, the way we showed you and explained you into that is that you would cross multiply. So if we look at this, that's what cross multiply means. We'd go across. So you'd have 30 times 5 on one side and x times 6 on the other side. Now again, the key thing is we talked about isolation, and we want to get this guy by itself. So right now what's stopping that from being by itself is a 6. And remember, this is x times 6. So to undo that, all right, we have to use the opposite operation. So in this case, we would divide by 6, because 6 divided by 6 is 1, and anything times itself is itself. So that's how we're going to get x here. But we also have to divide this side by 6 as well. So when you do that, all right, there's a couple of ways you could do that, but I know that 6 divides into 30 5 times, and 5 times 5 is 25. So you could also go 5 times 30 is 150, and divide that by 6, and you'd also get 25. Whichever way makes sense to you, use that. Maybe you can see the pattern here as well. You can see here, to get from 6 to 30, we times by 5. So what do we remember? What we do to the bottom, we also have to do to the top. So if I times 5, we get 25. See how that would work there? So it's another way of looking at it too. So I can't stress enough, understanding this concept is really important. If you don't get this, you need to message me, you need to get a hold of me, and make sure you understand how to do this, because it's a huge skill that you'll need, and you use quite a bit in math. All right, so there's some word problems here, and let's tackle one word problem, and let's see what we do. When we see a chainsaw mixture, now it's always good to highlight things and bring things out. It has 1 part oil to 50 parts gasoline, so I know I'm going to have to use that somewhere. How much oil should Clint add to the gas can if there's already 23 milliliters? Ooh, okay, so remember what we can do is we talked about it before, and this here was our ratio, 1 to 50. So how we did it before is we can convert that to a fraction, so 1 over 50. Okay, this part came first, and this part goes on the bottom. So this part here is in the numerator, and this part is in the denominator. So that's how I set up this fraction. Now, remember, you have to figure out, it says gas here, and notice how it says gas here. So these guys have to be basically in the same place. So if this is 50 here, 2,370 milliliters has to be in the bottom. And now what we're trying to figure out, all right, is how much oil. That's what we don't know. Now I used X. You can use O. You can use any letter you want. We just happen to use X. So now that we're set up with our fractions here, we can look at our previous work here and figure out how can we do this proportion here. Okay, we have 3 pieces of information and we're trying to figure out the fourth. So we really want to know what our x is here. So again, if you take a look and you cross multiply, you would get 2,370 times 1 is that, right? And then 50 times x is 50x. Now again, that's 50 times x. If I want to get this x in isolation, I need to divide by 50. If I divide this side by 50, as you know, I have to keep balance. All right, so that would be 2,370 divided by 50. So first of all, I'm going to knock off the zeros there because it's like 10 divided by 10. So that's what I did there. Hopefully that makes sense how I did that. And then what you want to be able to do, does 5 go into 237? Well, I don't think it does. But if we pulled up our, if you put it up a calculator and try to see what happened with that, I think you'd also get reconfirmation from the calculator that it would be the same. So the 50 divided by 50 is 1. So 237, all right, parts of oil you would need, all right, to keep it in proportion with the gas. All right. Hopefully that makes sense, and hopefully the math makes sense on that. If you have any questions, let me know. You can see here to finish off your worksheet, and the answers for some of the previous questions are also here. So hopefully, that helps you out a little bit too from the workbook. All right. Well, thanks for watching, and I hope this helped you out. And take care out there. You have completed 1.1 Fractions and Proportions.